Hello, everyone, and welcome to 321 Gang's webinar, Threat Analysis and Risk Assessment, TARA, in 7 steps using IBM Engineering Automotive Compliance. My name's Kara Rawlings, and I'd like to tell you a little bit about 321 Gang before we dig in. 321 Gang are a Platinum IBM business partner and a scaled Agile training partner. The Gang are the continuous engineering experts and an industry leader in scaling lean and agile practices. We offer our clients expert IBM and SAFe consulting services, training, and software tooling solutions to accelerate and drive results in the most complex, highly regulated systems and software engineering environments. 321 Gang's engineering expertise can help. Whether you're facing regulatory, economic, or technological challenges, 321 Gang offers industry-focused training and consulting. Talk to us today and learn how we can help deliver the solutions your team needs. Please take note of the question box in the control panel. We will be accepting questions throughout the presentation, and we will address them at the end. IBM's Bhawana Gupta is our presenter today. Bhawana is a product manager on the IBM engineering team, responsible for engineering workflow manager, or RTC, compliance, and agile at scale offerings. A certified SAFe program consultant, Bhawana works closely with customers on how IBM engineering solutions can be adopted for all things agile, lean, safe, and compliance. In her 24 years of working experience, she has interlocked with organizations and teams to assist them in their IT transformation initiatives and evangelize acceptance of software and systems engineering best practices and IBM offerings. So that concludes our introduction, and Bhawana, the floor is yours.
Thank you, Kara. Good morning, good evening, good afternoon, everybody, wherever you are. Today we are here to talk about TARA, or Threat Analysis and Risk Assessment. I'll start with some general stuff and move on to how the IBM ELM Automotive Compliance can help you perform TARA. So let's start with something straightforward, wherein we talk about the automotive industry and the standards that really regulate this industry. And if you look at, this is one of those industries where you have a host of industry standards that one needs to comply to. And these standards typically, though could be different, but they're very complementary in nature because their joint goal is the absence of unreasonable risk. So whether it's ASPICE or automotive SPICE, as we call it, which is basically looking at processes the development organization sets up to do their engineering work, or ISO 26262, which is for functional safety, and it prescribes processes and requirements to ensure that the product may cause harm to humans, are managed and minimized, or SOTIF, or cybersecurity, the recent most standard, which lays out the norms to protect that hackers can't change the behavior of the system from the outside world. We're all these standards are just to ensure that the work done, the systems and software engineering done for automotive are basically complying to these standards. So with that, I introduce to you IBM ELM Automotive Compliance, which is basically a tailoring of the IBM engineering lifecycle management for streamlining compliance to the automotive industry standards by adopting best practices from SAFe for agility and systems engineering for managing complexity and improving quality. The IBM ELM Automotive Compliance solution comprises a set of deployable assets, which included, along with process templates, each for DOS Next, workflow management, test management, GRS, publishing engine, report packages, views, and of course, what we call as the central guidance, which is the method composer process guidance, all built on a common domain model to provide an end-to-end automotive solution to support compliance and traceability. In release 1.0 and 1.02 of the automotive compliance solution, we delivered support for 2 important standards, that's automotive SPICE and ISO 26262. In our automotive compliance version 103 release, we introduced the support, or we extended the support to cybersecurity for compliance with UNECE R155 and ISO 21434. The new UNECE WP.29 regulation and ISO 21434 standard on cybersecurity basically is something that all automotive OEMs and their suppliers need to conform to and establish a management system, a cybersecurity management system or CSMS, and have them audited for cybersecurity and software updates. So I guess today the question we're focusing on threat analysis. The question is, why would UNECE or compliance with UNECE WP.29 R155 and ISO 21434 so important? That's because all new vehicles have to comply with these standards, and important thing here is it one or the other? And do I have to comply to both, or are they two related? Which ones should I be more worried about? So basically, ISO SAE 21434 is a means to achieve the goal UNECE approval. The UNECE R155 regulation calls for coordinated cybersecurity activities at all levels of the supply chain to establish a cybersecurity management system. Guidance on how to set up that system, how to set up that cybersecurity management system can be found in the standard ISO SAE 21434 Road Vehicle Cybersecurity Engineering. So let's look at this visualization to understand the scope of the guidance provided in the ISO 21434. The ISO SAE 21434 builds upon functional safety standard ISO 2626262 and provides a framework like it for the entire life cycle of the vehicle. The major components of this new standard include security management, project-dependent cybersecurity management, continuous cybersecurity activities, associated risk assessment methods, and cybersecurity within the concept product development of road vehicles. I kind of superimpose this into what I would like to map to how automotive compliance or IBM solution for automotive compliance enables handling of these CSMS work products. What you see here is basically the different process groups, if I can call this, or different aspects of the standard, and how the products, the engineering lifecycle management products, map to the work products and these process groups. The work products are highlighted in blue, and for today's discussion, we are concentrating or focusing on TARA, which is done as part of the concept phase, TARA threat analysis and risk assessment, which basically is based on our approach is based on attack potential as we've implemented it. So let's, before we really look at how you can do TARA within using our IBM Automotive Compliance, let's understand the TARA process a bit. So clause 15 of the ISO 21434 describes methods to determine the extent to which a road user can be impacted by a threat scenario. These methods and their work products are collectively known as threat analysis and risk assessment, or TARA, and are performed from the viewpoint of affected stakeholders like road users, OEMs, etc. The methods are generic and can be called systematically and from any point of the life cycle of an item or component, and are divided into broad steps, 5 broad steps, which can then also be looked at 7 steps if we look at in granularity, and that is what we're going to see in most of our presentation. The important thing here are the inputs. So to the entire TARA process or method, we get inputs like item definition, which is something that OEMs work with their suppliers, and they define the items that feeds the threat analysis. The threat analysis also is fed by vulnerability that may be detected at any point in time of the product life cycle, either through, let's say, active testing or through any cybersecurity event or any assessment. So together, these really feed the TARA process. So I'm going to talk in the next couple of slides, I'm going to talk a bit more about how TARA is the steps broken into steps in the IBM Automotive Compliance solution. So let's start with the first step, which is asset identification. And the asset identification is a very important aspect, wherein you look at basically from the item definitions given by OEMs or defined by OEMs, you identify the assets. So you identify assets, identify the category of the assets, and really for each item definition, you make sure that you have all assets listed. Here we use what we call the stride model, and the categories of the stride model for asset category. The stride is an acronym for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. This is used to identify the cybersecurity properties for the damage scenarios as well. So stride basically helps answer what can go wrong in the system we are working on, and each violation of a desirable property for a system is used to indicate the cybersecurity property. Continuing with asset identification, the next step really is where you identify damage scenarios. And damage scenarios are basically in this step you look at the diverse consequence or undesirable result due to a compromise in the cybersecurity property of an asset or a group of assets. For each damage scenario, identified, you basically look at the processes, the data stores, etc., and identify the impact of the damage. Once when you have identified all your damage scenarios, you do what we call a stakeholder assessment. And what a stakeholder assessment typically means is you identify the impact or you rate the impact to estimate the magnitude of damage or physical harm from the damage scenario on the stakeholders. The stakeholders are typically person or organization that can be affected by the damage, like road users, could be the driver, could be the person standing, or an OEM as well. A numeric value is used to denote the safety, financial, operational, and privacy impact, SFOP, for each damage scenario, and it is captured. These basically then will be used to determine the overall impact of the damage scenario in the next step. So that gets us to calculating the overall impact. When I mentioned the SFOP impact for each of the damage scenarios, that's individual values, and typically you would have one SFOP for, let's say, the OEM, one SFOP from the perspective of the stakeholder road user. But what is the overall impact considering all the stakeholders needs to be calculated. And here you would see in my presentation a small yellow dot, which means we have, at this point, we use what we call the TARA calculator. The TARA calculator is basically a utility that we provide that helps you calculate, correct, and refine these calculations across the TARA process. And you'll see some of this in the demonstration. Once you have the damage scenarios, you identify the threat scenarios. You identify the threat scenarios and you link them to the damage scenarios they can potentially cause. A lot of times I'm often asked kind of, do you identify the damage scenarios first and then the threat scenarios, or is it threat scenarios and then you identify the damage scenarios? It could be either ways. It really depends on how, what's your way of identifying. If your starting point is item definition and assets, then you really look at damage scenarios, what potential damage scenarios for an asset, and that will kind of lead you through to your threat scenarios. Whereas let's take the case of when you are looking at a vulnerability assessment. You identify threat scenarios first and then see, okay, what are the potential damage scenarios, and these damage scenarios relate to which assets. So it could be either ways. That's why in the one slide that I had earlier, we showed that as more of the same line. It could flow either ways. The next here is identifying the attack path. For a threat scenario, every threat scenario, there could be multiple attack paths. And when you identify an attack path for a threat scenario, you populate the attack, the attack path feasibility for every, or rate the attack path feasibility. So this is basically what we call an attack path analysis, which is basically the attempted deliberate action or interaction with the item or component or environment that has the result in an adverse consequence. One could choose a top-down or bottoms-up approach, or even a hybrid approach to identify attack and attack paths. Irrespective of the approach, the attack path or the set of actions that lead to the realization of the threat are listed here. And then it is assessed for or qualified using values that describe ease of successfully carrying out the attack. An assessment of elapsed time, specialist expertise, knowledge of the item, and window of opportunity using preset enum values is done to make this easy and reduce manual error. Next, of course, is the TARA calculator is used to calculate the attack potential, which is like a kind of a worst case scenario that suggests the attack feasibility rating of each identified attack path. Like I said, you could have more than one attack path for a threat scenario, so it kind of takes a cumulative. Now, what we've done up till now is do the threat assessment of the TARA, so the TA of the TARA. And now what we are getting into is the RA, or the risk assessment based on the threat assessment, threat analysis that we did. We're going to do the risk assessment. So the calculating the risk level is how you start with the risk assessment. And here you use the TARA calculator to calculate the risk value. The risk, basically the mapping of the associated overall impact of damage scenario and the attack feasibility rating that we've calculated in the previous steps are used to calculate a risk value. It is done using a risk matrix as suggested by the standard in the ISO 21434 standard. The risk matrix uses an ordinal scale of risk value 1, 2, 3, 4, and 5, where 1 represents minimal risk and 5 represents the highest risk. The TARA calculator calculates the risk value based on the symmetric risk matrix recommended by the standard in the solution. Finally, the risk treatment decision. So we've kind of assessed the risk or calculated the risk level, and to complete the risk assessment, you determine the risk treatment. So this risk treatment decision is to reduce, share, or retain. These decision options are not mutually exclusive or appropriate in all circumstances. The risk value does influence the risk treatment decision, but does not immediately imply an evaluation concerning the acceptability of this risk. It is influenced by other aspects that might not be represented in the assignment of the risk values, such as specific constraints, trade-offs, respect to other risks, etc. But in terms of the way forward, if the risk treatment decision for a threat scenario includes reducing the risk, then one or more corresponding cybersecurity goals are specified. If the risk treatment decision for a threat scenario includes sharing the risk or retaining the risk due to one or more assumptions used during the analysis, then one or more cybersecurity claim is specified. And this is really kind of important because the decision of retaining or reducing and sharing the risk really determines how it feeds what you could call high-level requirements to what needs to be done for product development. When we say it's a cybersecurity claim, it's more like some kind of testing is done, and you have to see if there are any defects. So the claim that you're making, is it right? Is it correct? Is it incorrect? And if it's incorrect, then the defects that you need to work on and resolve. And if you're looking at reducing, then it is more about implementing something. That means that the product team needs to be given high-level requirements, which basically map to cybersecurity goals, and the whole product development life cycle follows. So as I spoke about those steps, you may have noticed at the bottom of the slide a couple of listings with this kind of icon, and this really was to indicate the reports that we have at every step. Their reporting is very important for us because we understand this is what really drives an audit, but also clause 9.4 requires a verification report to confirm correctness and completeness of the result with respect to the item definition, completeness, correctness, and consistency of risk treatment decisions with respect to results, completeness, correctness, and consistency of cybersecurity goals and claims with respect to the decision. So keeping that in mind, to satisfy for the cumulative work product, we have these reports that you see here. They show coverage, gap, and also highlight the correctness and completeness of the method of TARA. The TARA reports show a complete view of the work products of all steps of TARA. For example, if you look here, these TARA by item and TARA by assets, I guess it can make one think, why do we have two TARA reports? They're both coverage reports, more like traceability reports. OEMs generally like to view results of the TARA group by item, whereas a supplier may like to see the results of TARA as per the assets. So we've kind of kept in mind that the solution could be used by OEMs and their suppliers, and each would like to view the data, the same data, because what we're advocating is a single source of truth from different perspectives. Violation reports highlight inconsistencies and gaps during the process to ensure correctness, completeness, and consistency. So, if I was to talk about this, the stride violation report, something as colorful as what you see on my slide here, which highlights as per stride what asset categories really need to have some kind of damage scenarios identified. So the red, green, and the yellow indicate. So red says the cybersecurity is not expected to have, and yet there is something present, whereas the yellow says it's expected to have present and it's not present, whereas gap basically means it's not expected and it is also not there. So it's kind of there. So we have this stride violation report, and we also have reports that really show accepted. I mentioned that it's important to highlight the consistency of the risk treatment decision with respect to cybersecurity goals or claims. So we have reports to highlight that as well. With that, so this is just kind of summarizing all that I spoke, right? And I'm hoping to take you through this in my demonstration. Just a quick summary before we get there. The starting point, like I mentioned, could be either identify the item definition or the assets to kind of identify on the damage scenarios, or could also be the threat scenarios. For the demonstration, I will start with damage scenarios. We look at assets and related damage scenarios, and we'll move into how you assess or do the impact rating. For the damage scenarios, identify the threat scenarios, calculate the attack feasibility, calculate the risk level, set the risk treatment decision, and map it to cybersecurity goals and claims. Okay, so with that, I'm going to switch to my other screen. So what you see here is a part of the automotive compliance solution. This module is only available in the templates provided by the automotive compliance solution. So we are in a module of the type asset, and here we see a listing of our assets, the asset category, whether it's a data store, process, etc. And this is important because this will really determine the stride cybersecurity properties for each of the damage scenarios related to it. The asset is compromised by damage scenarios. In this case, you can see the asset authentication key is compromised by a number of damage scenarios, and of course the asset is related to the item definition of the basic cruise control. Okay. Next, we move to the TARA module. Of course, this is linked. I could always have clicked on one of these, which opens this. In the interest of time, I've actually, have this here. So let's start looking at. So we start with the damage scenario. We saw that the asset authentication key is compromised by a number of damage scenarios, and these are the damage scenarios here. You can see that it's listed in the compromises column. And when we look at any one of the damage scenario, it is associated with a cybersecurity property. So you could select any cybersecurity property here. Now, for every damage scenario, you do a stakeholder impact. And if you look at the views in the module, we map this to the steps of how a TARA is really performed. So the damage scenario identification is done. Then you do a stakeholder impact. Now, when you look at stakeholder impact, I mentioned you take one. So we are talking about the damage scenario, user unlocked the car but is not identifiable. That is 4100. And this one damage scenario is then assessed, or the impact is assessed from both the road user as a stakeholder and the OEM as a stakeholder. These are the SFOP impact that are populated, and you would see that each of these impact values are basically values that we have picked up from the standard, and you could select this. So once you have the impact for both these, it could be one stakeholder, it could be two, more than two. But in my demonstration, I have road user and OEM as stakeholders. Now, for this, next step is you can calculate the overall impact. And that's typically the step where we use the TARA calculator. So I'm going back to the damage scenario 4100. And currently you see that the SFOP, that is the overall SFOP for this damage scenario is not set, right? You see the two that are associated with this, and you see we are going to use, or the TARA calculator is going to use this. I'm going to just get myself some real estate here. Let's refresh this for a sec. I think timed out. Okay. So I'm going to go and select this particular damage scenario, and if you note that the TARA calculator is smart enough to really realize what is selected and what is going to be expected from it based on the selection. So when I select a damage scenario and the view, it understands that this is the place where it's going to be asked to calculate the overall impact. I'm going to create here, I'm going to demonstrate how we can use it to calculate, but you could also use it to check. So if it already, if it's something that somebody has added manually, you can use to check. You could also, so check only lets you know, okay, something is wrong, but if you wanted to check and correct, you could use the option correct all. So if I scroll down, you will see that on the basis of the values that were there for each of its stakeholder impact, it has calculated a worst case scenario for the overall impact here. Okay, so with that, now we have damage scenarios, and our damage scenarios, we have calculated the overall impact. Next is the threat scenario identification. So you identify threat scenarios and you associate those threat scenarios with the damage scenarios that you have. So let's take this here, and you will see that this one threat scenario is associated to more than one damage scenario. For one of those, we have the overall impact calculated. For the other, we don't. And basically, you know, you can and for this, the next step is to identify the attack path. Now, the attack path is, like I mentioned, it basically associates with a threat scenario, right? So we see that there is this attack path stolen identity, and you have this associated to a threat scenario. Like I mentioned, you do a kind of a rating or an assessment analysis of the attack path, and each of these, elapsed time, specialist expertise, etc., are aspects that you use to rate your attack path or analyze your attack path and then calculate a feasibility rating. So here you have different values, again, all picked up from what the standard recommends. Once you have added these, we need to calculate the attack feasibility. And again, here is one step where we could again rope in our Tara calculator, and you would note here that now it says calculate the feasibility rating. So I'm going to go ahead and select that. So it's actually gone ahead and populated high. You could also, like I mentioned, again, we still have check all, correct all for all this. And so now we have attack paths. You could do this. I'm demonstrating just with one row. You could do this like a bulk action as well, whether it's calculate, check, or correct. Bulk actions are possible. Okay. The last thing that I'm going to skip a few things here, but now we've done the threat analysis. We get to the risk assessment part. And on the risk assessment, we basically look at the threat scenario. And we've already got the damage scenario. We've calculated the overall impact of the damage scenario. We've got the attack path and its feasibility. So that is also here. And now what you need to calculate is risk value, and that will give you the overall risk level, right? So again, we could use the Tara calculator. So it says risk values are incorrect. Click correct, because you have something here which is 4, maybe something that's manually added. So I will click on correct all, which typically means that it will validate what is already there and also then populate. Okay. So if you see here, there are refreshed values here where it calculates the values here for us. Based on this, you take a risk treatment decision. And like I mentioned, this is really not exclusively mapping to the risk values or the risk level that is identified. This is more like an, it considers a lot of things, and you choose to do either reduce, share, retain, or avoid. Avoid is something that generally will flag off in our reports that you have chosen to avoid a risk which is auditable. Like I mentioned earlier, reduce means that it should be associated to a cybersecurity goal. Share and retain would be a cybersecurity claim. I'm going to jump over to the threat scenario traceability to kind of show you how this really has transpired. So if we look at the threat scenario that we were, so we could either see it by damage scenario or threat scenario. I'm choosing to show you the threat scenario. So we have the threat scenario. It is it causes this damage scenario, and it's realized by this attack path, and it's justified by this cybersecurity claim, right? So there is a complete end-to-end traceability. And like I mentioned, we have your downstream. The same could be also for a cybersecurity goal. So in this case, you see it's reduced by a goal. And these goals are basically then what becomes the high level. It acts like a high level requirement to your security requirements. And I'll just skip to a module where you see your cybersecurity goals, and you see that they reduce a threat scenario and they're satisfied by functional cybersecurity functional requirements. So the entire downstream traceability of requirements during product development from Tara can also be managed. quickly summarize reporting. I showed you a slide earlier which listed all the reports that we have. This is the kind of dashboard that we have. We have a number of reports here, and I'll kind of show you a few. So this here is a TARA by assets. Like I mentioned, we have TARA by item definition, TARA by assets. This is TARA by assets where the grouping factor is the assets. So you see assets, you see the damage scenarios, related threat scenarios, the decision, and based on the decision, then it actually has the goal or the claim that it's linked to. So this is more like a traceability report or a coverage report. We have what I mentioned, or I call violation report. So this here actually tells us the threat scenarios with traceability, which is inconsistent with the risk treatment decision. So here, if we see that you have a threat scenario where we are saying the risk treatment decision taken is reduced, that means it's missing a link. Ideally, there should be a link here to a cybersecurity goal. You have share. Here again, it's missing a link to a cybersecurity claim. Here you have the decision is reduced, and when it's reduced, it should have a link to a cybersecurity goal. But in this case, it's an unexpected cybersecurity claim, which is not right, because the decision is to reduce. So violation reports like this highlight the inconsistencies and help you correct this. So this may not necessarily, this could be considered an auditability report, but this would also be something that helps the security engineers or the SREs to really work on or use while they're working to ensure that audit is really a byproduct and not activity of its own. Okay. With that, I'll just switch back to the presentation. That brings me to the end of the demonstration. I'll switch back to my presentation and go back to the slide that I started off with, just summarizes the process that we just saw, and the different points at which the TARA calculator can be leveraged. The output being you have cybersecurity goals or claims which act as high-level requirements to feed the entire product development from a security perspective. Okay, so I'm going to keep this slide and I guess I'll request Kara to open the floor for questions if we have any.
We sure do. Okay, let's get started here. So in TARA process, do you calculate CAL, cybersecurity assurance level?
So we still don't calculate CAL because the standard doesn't have, so we have the field for CAL, and the CAL are typically at the item definition level. So we have fields for the item definition that have CAL. You can specify the CAL. Do we auto calculate the CAL? Not as yet, because the standard doesn't give what should I say, a guidance on the auto calculation part. So as of now, this is manual, and we're hoping as the standard matures and evolves, we are able to implement the auto calculation as well.
Great. Risk matrix. Is it ISO SAE 21434:2021 compliant?
That's right. So we have picked up the risk matrix, the symmetrical risk matrix as defined in the standard. The standard basically recommends a couple of matrix, we've used the symmetrical risk matrix. And that is what you also would see on the Tara calculator, that little color-coded visual, if I can call it that.
Okay, next question. How collaborative is the tool? Is it easy to update?
Oh yeah, the tool is typically for parallel development. So you know, a lot of people can be working and collaborating on updating the values as, you know, like of a collaborative process. You can use the tool to even collaborate in terms of comments, discussions, document any decisions that you have taken. The most important part is this is not a standalone tool where you just do Tara and it's kind of on its own. It really feeds or can trace down to your requirements or your entire product development for that matter, right? Feed your requirements, feed into your planning, get associated to your defects or problems, issues, vulnerabilities. You could really feed that entire thing in. You could also, a lot of times, you know, when a lot of mature teams, when they look at identifying attack paths, they take different routes to identify attack paths. Some kind of just do a textual one-line thing, that's a possible attack path. Some may kind of create a lightweight diagram. We have diagramming capabilities as well, right? Some really go the full path wherein you could say that I'm going to do my FTA using you know, something like RAML, you know, modeling. So we have integration points to Rhapsody where you can use RAML, that is risk assessment modeling language, to do your analysis and fault tree analysis and really tie it into your attack path and feed this entire Tara process. So, you know, from a very simple to a very mature way of doing attack path through integration. So it could be as simple as complex, depending on the maturity of your team. And of course, you could extend it through the product cycle, development life cycle. That's a great question. Thank you.
Great. I would like to see how traceability is ensured.
So this is a great question. I showed you one of the reports where we have coverage, but we also, I don't know if you missed, and maybe I should switch over to the view for a second. I think this is a great question, and sorry, I'm kind of jumping here. So if you look at this module where we were actually performing Tara, right, you see that the actual action was from view 01 to 06. But then I have 4 views which actually are checks. So 01, damage scenario, missing stakeholder impact, shared all modules. So when I click here, it basically shows me while I'm working, it shows me all the damage scenarios where I do not still have any stakeholder impact. So your missing traceability is identified as you work. So it kind of becomes like checks while you're working. So that's a great question. Something in the interest of time, I skipped, but thank you for the question because I could point this out.
Great, next question. Can you say when we use Tara by item or Tara by assets, does that have a preference in relation to being an OEM versus tier 1 or tier 2?
I wouldn't say it's like one, it's an either or. It's sometimes a preference. So we kind of created reports for both. It's not that OEMs would not like to see it by assets or they only see it by item definitions. It's just like, I would say, a preferred way because of the level of abstraction. An OEM typically would have many suppliers and they talk the language of the item definition. Whereas if I am a T1, T2 supplier, I'm the level of abstraction that I'm working at is more assets. But if I am doing more than one asset for the same OEM, I may be interested in looking at this whole process from item definition point of view as well.
Okay. Can Tara be linked with HARA? How?
Oh, that's a great question. So we have an entire HARA built in within this solution as well. For the session today, we concentrated on TARA, but we have the HARA as well, where you could do your hazard analysis and you have a similar calculator. And since I'm here, maybe I just give you kind of a peek into the calculator, very similar to the TARA calculator. We have a HARA calculator. So the HARA calculator basically looks at hazardous events and uses the hazardous events. You can set up exposure class, severity class, and controllability. And it uses this to calculate the ASIL value. And those ASIL values then, you kind of use when you set security goals and even decompose your safety goals, and you decompose your safety goals. Where do the two meet? I think the meeting point is item definitions, and let me kind of show you that here since I have some time. Bear with me here. It. Module. So if you see, I have used the assets module, which is a cybersecurity thingy, to come to item definition. So you have item definitions, and there is item definition, which you see the item links to hazardous events and the assets that we just saw, right? And these hazardous events are basically what the HARA will assess and analyze. So the tying piece is the item definition. There is an entire module working for ISO 26262 within the solution as well. So like I said, it's automotive SPICE, which is extended into a functional safety module, which is then extended into a cybersecurity module. You could choose to do only automotive SPICE, but you could, or any one or two of those in any combination, but you could also use the entire gamut. So yeah, great question. Like, it's a great segue to really talk about the breadth of the solution that we have here.
Okay. Can you please elaborate on the unexpected CS goal and the CS goals and the CS claims?
Oh, okay. So I assume you're talking about the report that we have here, right? And I think I'll just go back to some of the things that I mentioned. So when we calculate the risk value, basically the risk using a risk matrix, the risk matrix uses the ordinal scale 1, 2, 3, 4, 5. And based on that, you kind of arrive at a risk treatment decision. And the 3 risk treatment decisions that you could do are of course, there's a 4th one, avoid, but let's put avoid for now. Mainly it's reduce, share, or retain. And these decisions are not mutually exclusive, or they don't have any mapping that the calculator can calculate, because there is, kind of a lot of representation, other risks, trade-offs, etc. But the thumb rule as defined by the standard is, if the risk treatment decision for a threat scenario is reduce, then you need to have one or more corresponding goals. And if the risk treatment decision for the threat scenario is share or retain the risk, then you have one or more cybersecurity claims. Now, keeping that in mind, and I just use this as this report here, this threat scenario, the risk treatment decision is reduced, which means it needs to be associated to a cybersecurity, one cybersecurity at the minimum. And in my sample, there is no cybersecurity, related cybersecurity goal. That is why in the column it shows risk treatment decision missing a link. Similarly, if you look here, it's reduced, so the same risk treatment decision, but it says that you have a link, so there's no missing link, but it's an unexpected link, which means it should be linked to a cybersecurity goal, but you have linked it to a cybersecurity claim, which basically means that you should be doing development, but you're saying or assuming that, oh, this is all fine, and I just have to do a bunch of testing and I would be good. So either the decision is not right or the linking is not right. So that what we've done is highlight that inconsistency in this report. I hope that helps answer the question.
So it looks like a couple follow-ups here. So it says, are you saying that you put both items for safety and cybersecurity together?
Oh, this concept is only for the cybersecurity. This concept that I just outlined, when we have safety goals, there is no notion of safety. That works differently. This report here is just for the cybersecurity.
Okay. So the question is how to combine or at least consider their interactions. So I'm not exactly sure what that applies to. I'm not sure if you do.
Yeah, I think we had a similar question, at least that's what I assume. And I mentioned that item definition is the tying point, which I showcased in this here module, wherein you have hazardous events. And so hazardous event is a safety concept and its equivalent is the threat scenario. Now, the threat scenario and the hazardous event may be all associated to the same item definition or different item definition. So that, at least for our implementation, that's the tying. But if you feel there's something else that you're looking for, I think yeah, that may need a follow-up, maybe some clarification that I would need.
The question was about doing them both previous, not the question for missing links, safety and cybersecurity. Does that help?
Oh, okay. Doing them. Okay. So they're two separate processes. And that is why you would see if I say we have a separate HARA module. So they're two, if I don't want to say mutually exclusive, but exclusive processes that consider different aspects. One, functional safety, one, cybersecurity. The nature is very similar. And if I could kind of make that statement that the whole concept of TARA is based on the concept of HARA, because ultimately 21434 is based on 26262, right? But I don't think it's like, oh, you need to have the hazardous event, because the hazardous event is looking at safety, whereas the threat scenario is looking at cybersecurity. So they are looking at different aspects, all related to managing or minimizing the risk, but different aspects, safety and cybersecurity.
Okay. Next question, can you export cybersecurity requirements from the tools to other requirements management tools, such as Polarian, JAMA, or just to MS Word or Excel?
So you could export it to Word and Excel. In fact, you could do it from the tool, the module very much itself, provided you have permissions as a user to do that. We also have a reporting utility which kind of creates a document. If, because as a supplier, you may need and if your OEM is not on the same platform or vice versa, you may want to provide documentation to the other stakeholders. You could use document generation to generate a document. So we have, in fact, we provide the templates for such document generation in the IBM Automotive Compliance solution.
Okay. How is TARA linked to the rest of doors? So what happens after having the CS goals defined? How do I proceed in the tool?
I think when you have the cybersecurity goals, and I think the best way is to look at this. This is my cybersecurity goals module, and you will see it is satisfied by cybersecurity functional requirements. And we can quickly open the links explorer for you, and maybe just maybe kind of filter is satisfied by. So cybersecurity goals are satisfied by cybersecurity functional requirements, which in turn will be satisfied by cybersecurity technical requirements. And if you really see, we are moving from a system to a subsystem kind of thing. And technical requirements by software or hardware requirements. And these are then requirements then that get implemented, tested, and delivered. So you endorse next, basically. Now, if I was to create this kind of visual from the threat scenario, you would see the threat scenario linked to the goals, the cybersecurity goals, the goals to the requirements at different levels.
We have several other questions. Would you like to continue, or do you want to maybe address these later since we're running out of time? I don't mind. Okay, it's up to you. We can address a few more if you'd like.
Really interesting. I'm really happy that there is so much interest in the solution.
There's a lot.
Yeah. So maybe let's time box this to another 5 minutes or so and see how far we get. And I'm happy to take the questions offline and respond.
I think we should do that because we do have quite a few more. So thank you for your input.
Let's do that then. Yeah. Okay.
Yeah. Okay. Well, it looks like we're going to wrap things up here, and this concludes our presentation for today. Some folks did ask if the session was recorded, and it is. It's being recorded, and we're going to get it up on our website within a few business days. I'd say check back in about 3 days or so, and it should be up on our website. So if you would like some more information or have any additional questions, please email us at info@321gang.com, and we will get back to you. Okay. Thank you, everybody, and thank you so much, Bhawana, for the fabulous presentation.
Thank you so much, and I'd love to, get back to the rest of the questions, and yeah, Kara, we'll stay in touch with those.
Got it. Okay. Thank you. Bye-bye.